Thank you. I promised to give the talk in English, and I can't refrain from it because the talk is being streamed, is it? Yes. So I will stick to English. I apologize for that. Although maybe nobody wants me to really talk English, but let's see how it goes. I mean, the notes are in English, so why not talk about it? What's it about? This is the description on the Linuxtage homepage. It says systemd is dbus implementation. It's Python async IO binding. This is what it's about. It's about programming against dbus and programming dbus services, at least to some little extent, with the Python sdbus mapping binding. It's about programming. This is just an abstract. I put a link to the talk material. This is what I have here for myself in order to not get stuck in the material. So what's it? I got the slides. The slides are not really slides. It's HTML from my homepage. And what's it about? At least that's the title. What's that about? It's about dbus. You might know Leonard Pöttering with this whole systemd universe. He wrote a great article at his own blog where he introduces the systemd dbus implementation. Dbus is a protocol. We will look into that. Dbus is a protocol. And the systemd guys, for systemd alone, chose to write yet another dbus protocol implementation, which is lightweight, it's tiny, and it's fast. This is what they needed. There is a systemd dbus binding in a separate project. It's available from PyPI, it's well documented, and so on. It uses the C implementation of the Pöttering guys underneath. It has it's actually two bindings. One binding is the blocking binding, where you say you call a dbus method. We will see what that is. You call a dbus method and insist in the return value of it being the return value of a function. So this is blocking. You block there. And the second binding in this entire binding is a Python async IO binding, which is really cool. And this is what I will show you, how to program against this, how to use dbus with this binding, with this entire universe. And let's see what dbus is. What's dbus being made for? Originally, dbus was made for the desktop, to bind these components of the desktop together. For example, when you see, I don't know what the physical incarnation of this menu is, but I suspect it's a separate process which communicates with the window management. I'm not a desktop expert. I'm using it because I'm decadent, but otherwise, I love more this stuff, terminals. This is more my world. And here is Spotify, for example. This is Spotify, and I want to show you what dbus is used. For example, so when I play this play and pause button on this function key bar, you hear Spotify is unpaused. It plays, and now if I hit it again, it's silent again. This is dbus. Somehow the desktop intercepts the keys and sends over dbus as a client this play pause request to the Spotify dbus server. It's a client and server. Not actually a relationship. There is a broker in between, which is the dbus broker. We will see how that goes. But let's stick to Spotify for a moment.
Play music. Do you have a license? Because please only play a license.
Yeah. Not even a second.
Yeah,
okay.
A second, I think it's okay.
Okay.
Please not bother.
Yeah. I'm not playing the entire song. So, okay. dbus. What else? Let's look closer into it. There's a program named dfeed. It's what is it? It's spelled like that, D feed, not D bus, but feed. I have no idea how these guys get to their names. I choose the session bus. They're actually in the system, nowadays Linux system, there are two dbus instances. One is the system bus with all system managed disks and suspend and what else, all this system management stuff is there. And the session bus contains the session bus. This is started per user. When I log in, I get an own dbus instance. I get even an own systemd instance for which manages my seat, my login, and so on. But this is not about systemd. This is also not about Spotify, although I start with it. On this session bus that I chose here, I find this media player. I find what's this? This is it shows me the services, all those dbus servers which are connected to my session dbus instance. So this is quite a lot. Flatpak authenticator.oci, I have no idea what that does. I know what Flatpak is. File manager, there is the Flatpak and so on, what package kit and so on. And further down below there is Spotify. eFeed is rather convenient. It lets me search, and it updates dynamically. If the service vanishes, it's gone from the dfeed display. So to say, this is the service. This is one such service. This is one process, namely that one. Okay? This is one process. The process has connected to the dbus. It has a name, which is this org empris media player remote interfacing specification. This is how the names get together. It's not only made for Spotify, it's for XMMS and whatever media players there are. And this process, this name, this service, which is named in that way, has an object. It has multiple objects. We see objects here. It hosts objects in one process, namely that process. And it's this media player 2 object. That's the target of my call now. And it has a couple of interfaces. This is dbus. Services have objects, one or more objects. Zero, more object, although zero does not make much sense. And objects are reachable through different interfaces. Yeah? This is object orientation at a very high level, so to say. So what you see this dbus introspectable. This is made by the binding. This is made by the library the Spotify guys use. When they say I want to glue my application to dbus, they get this introspectable, dbus introspectable interface by the binding, which supports the introspect method call. So I am introspecting the object. I'm introspecting the object, and this is a little crappy. You cannot enlarge very easily, but let's execute the method. Where is it? Yeah, here is it. And now when it's done, I can enlarge. And this is dbus introspection. You get a large bunch of incomprehensible XML where the methods are described, where the parameters and the return values of the methods are described. In XML, it's machine readable, although not very human readable. So let's go away from that. And let me choose this media player 2 interface, which contains, as it turns out, these methods next, which you might know from the buttons on your laptops, so to say. So when you say play pause, this sounds like, and it is, sounds like the implementation of the behavior of this play pause button that I have here. So let me double click here. It does not take any parameters. It has no return value. It's just a toggle, play or not. Music off. Okay? This is dbus. Yeah, that's dbus. Okay, so let me hide this one and look what's further going on. Ah, yeah, Spotify. Let me reuse that one. There's another one. We saw this dfeed, this introspection user interface where everything's clear and everything's cool. But unless you, it's not made for programming. So when you want to program, you know a couple of things beforehand. For example, you know where there's this bus control program, which comes out of this system dbus implementation. It's a command line program, which is really cool. So I say bus control, connect me to the user bus. That's what this parameter does, and call a method that I'm about to specify now. And now, with this really cool tool, I type a unique prefix of the method and the tab key. Yeah? Command line completion. It offers command line completion. Where is it? Oh yeah. And it completes me the service name. This is the org empris media player blah specification media player 2 Spotify service, which is this program. And then again I specify the object inside this service. There is an object named org / on the path. These are object paths. Empris / media player 2. That's the object. Yeah, that's the object which is hosted by this service. And this object has a couple of interfaces, and the interface that I choose is the media player 2.player interface, as we just saw in the D feed. What I'm doing here is I'm about to call this method inside this object via this interface. So where is it? Inside this object via this player interface, so to say. That's what I'm doing. There is no hotkey to hide. And then I hit tab twice, and the command line completion of this very cool bus control program offers me the methods that I might call. And I'm choosing this play pause method. And now off. Okay? That's it. This is dbus. It's very simple. Nothing happens here. No parameters are passed, and no return value is there. The question arises: which format do the parameters have? This is all specified in the dbus specification. There is a syntax for it. We will get into it maybe, but this is not so important. It is manageable, and it is understandable. You read about the data types. There are a couple of combined data types like structs and dictionaries and so on, tuples and dictionaries as we know them from Python. But this is not so important. Much more important is the bigger picture. Yeah, I want to bring you that. That was the picture of. This is the dbus service which comprises Spotify. Let's say this is the Spotify instance in dbus terms. As we saw, the service name, this is the dbus. We will see shortly what the dbus is. It's not a bus, a line. It's a dbus daemon. It's a daemon, a server in the middle, a mediator, so a broker in the middle. But let's say there's a cable where somebody attaches to it. It connects via Unix domain sockets. And after a service has made that connection, it gives this connection a well-known name, org empris media player 2 Spotify. This is well-known. At least the prefix until media player 2 is well-known, and the others are very, no, this is much too detailed. That's the name of this service. This is what we saw in the dfeed output. And this service hosts one object. Yeah, services can host many more objects as they want. Yeah? And this media player 2, this org empris media player 2 by path object, offers functionality through different interfaces. Where we have seen this org free desktop dbus introspectable, which makes introspection. Then there are a couple of properties interface which serves properties from a dbus object that declares to have ones. And of course, it has to be a media player by implementing these two. There are two interfaces in the Spotify case, respectively in this empris specification. let's dictate that. Yeah, that's it. That's the debug service. This is Spotify and what else? And this is the real, let's say this circus, these bubbles are processes. These are processes, and there is one very important, this is the important process, this is the debug broker. This is the process in the middle which mediates. Let's say the Spotify client wants something from the Spotify service in the upper left. So it tells the debug broker to tell him to do something for him. So, and what do you see? Spotify client makes a call. The call hits debug broker. He decides, there is a target of the call, and he mediates that call unmodified onto this Spotify service, which then reacts, formulates the response, sends it back into debug broker again, which then finally hits the client who waits in some way or the other for this response. And you see that this is not cheap. Performance-wise, you cannot travel mass data over these debugs, because for this simple transaction, play pause, the Spotify client has to be woken up. Obviously, he makes the request, but then he passes control to the debug broker, who mediates it to Spotify. So context switch from here to here, from here to here, and for the response all the way back to the originator. So this is 6 or so. Correct me if I'm wrong, context switches, which it's not entirely cheap. You use it only for occasional requests to do something or whatever. So, okay. So let's see how we can program that. I mean, what I showed you was this defeat, clicking about and doing something and all graphical. Then there was this command line bus control program. There are a couple of other such programs, but I want to program this on my own. So what I do is now to start Emacs and start to and I prepared something, of course. What I'm doing here is let's look afterwards in this emprise Python module. This is something that I wrote to get what I want, and then I instantiate a client for this Spotify player via this Spotify player interface. Yeah, let's see the way defeat again. Defeat. It's the same. In this service, from this object, I want to go into that interface and call that method. That's it. Service name, object name, interface, method. Yeah, that's it. And that's what I do here. I request a connection to the bus. I'm a client, so I'm not supposed to have a well-known bus name. I'm just a transient client which comes and goes as I want. Here I specify the service name, and that's the object path, as we just saw. And then I say Spotify play pause. This is a method that is generated for me by the Python sdbus binding, by the Python binding for this dbus thing that I use. Yeah, so let's say Spotify client. Yeah, please. Okay. So what I'm doing here is to instantiate a proxy. This is how it's for the object orienters among you. This is a small object which sits inside the client, which mimics that interface, which fits client server onto that interface. But does just the communication. It does not implement anything. So this emprise player class that I import from here is obviously something that is special, which defines the method that I use down below. So let's look into this emprise interface and this class. So what this does, an emprise player. This is something that I wrote in order to reach this and only this. There are next, previous, and a bunch of other methods. I need only that one for these purposes to show you what this does. There's this employees player class, which is it inherits from the dbus interface common. This is the blocking interface out of the sdbus universe. Here is it. And it defines a method that does not implement anything. It's a stub. It's only there to make proxies, so it's not supposed to implement anything. The dbus binding implements the client-side proxy, and this is a decorator. This is here much of the magic happens. I mark this as dbus method. This decorator usually has parameters named. These are the request parameters. These are the response parameters, but there are none. This is none. Void, back and forth. So there are no parameters. And what I get is a working client-side handle to the object that I can use, like the interface specification says, play, pause, next, and so on. Yes. What's next? Oh yeah. And there's another one. There's another one. Another class in this. I want to show you that shortly. What this is. I don't know how this specification came about. It's the Empress Media Player 2 specification, version 2. I don't know. Which defines the player is usually one object inside a larger application which has other responsibilities, namely track list, playlist, whatever. I have no idea. This is the player interface, and as such, it supports only player-relevant functionality, as opposed to the media player, which I guess it has quit and raise. It's application-wide functionality, which is exported over this interface of the same object, which this is, and this is something that I defined, quit. I don't care about raise. I do quit. I write the program which quits not the player inside Spotify, which cannot be quit, but rather I quit the application. I say quit. Then gone. Quit. Dbus. Okay. This is dbus. In short, very short words. A couple more words is defining interfaces. Yeah. There are a couple, many implementations of dbus. The original implementation is called libdbus. Libdbus it's really deprecated these days because it's real crap. I believe the Qt dbus implementation is based on it, but I'm not entirely sure. Then there is another, and people have started to re-implement the dbus protocol, functionally equivalent, but a little more fit for their application. So, for example, the GNOME guys, or these GNOME GTK support libraries, which are the underpinnings of the GNOME desktop and GTK applications. The GIO library has one implementation in C, which has nothing to do with the original libdbus, except that it implements the same specification. And as I told you, the systemd guys chose to implement their own because all the others did not fit. They were using the GIO, I think, before, but this was much too fat, much too coupled with the glib. They don't need glib. They are systemd. This is systems programming at a very low level. They needed their own implementation, and for Python, there are a couple of bindings. It's actually much more complex, and there are much more bindings and much more implementation. There are native Rust implementations coming up, but this is C and Python. There's dbus Python. This is dbus Python. This is a binding for the original deprecated implementation. Then there is PyDbus. Formerly, PyDbus was called Python dbus, not to be exchanged with dbus Python. Now they chose to rename it to PyDbus a couple of years ago. This is the uses the GIO implementation, and there is Python sdbus, which I will focus on today for the remainder of the talk, to show you how that goes. So let me bring I don't know if this is real world. This is an example that I wrote as a scenario of how to bring your own system, which is object-oriented, into the dbus universe, how the steps are and how this can roughly be done. The use case is irrigation, giving water to plants by having a sensor and a switch which controls the water. Two of them, many of them. There are irrigators. These are the software counterparts of sensors and switches, the logic behind the irrigator 1, irrigator 2. And the entire thing which contains the irrigators is called irrigator system. And the goal is to wrap all these into a dbus service with the same naming, with roughly the same interfaces via dbus as the local interfaces are. And it should be exported on as a service on a well-known name. So this is what I do for the rest of the talk. Let me show you that shortly, how that goes. It's not about the local implementation. Oh, shit, I did not preload the. This is what I'm showing you now is the local version of this irrigation system. It instantiates itself from a configuration. You get a handle to the system. Here it is, to the entire system, only in the local case. And then you run a loop in a 1 second interval where you compute this, you get the sensor values, compute the necessary, switch on water, switch off water. Yeah. However, the values of the sensors are, and when you start this, let me show you the config file. Config, that's the configuration where I build up this irrigation system, and you see it contains 2 irrigators, one for the tomatoes and one for the beans, with low and high watermarks and the sensor and the switch. So when I start this, let me do this shortly. Irrigation local. A config file named configs. It runs, and what it does is there is nothing real. I got no sensors and no switches. I have only files. So when I say sensors, the sensors are 0% moisture, 0% humidity in the ground. So water is definitely needed. So when you say, so the switches are on, water is running, moisture is still at 0%. When I then say, do me both at 100%, which is not absolutely realistic, because this would mean you put plants percentage of put plants in a pot of water and drown it. So what then happens is, for example, the beans switch goes low because no water is needed, obviously, anymore. Same with the other switch. This is how this thing works. This is ridiculously trivial. But I mean, the system is not ready. I started to over-engineer first. So I started with the dbus first, and then I just for you, figured out what the functionality could be. Yes, that's it. And starting with this, let me go back to this Spotify client and say how such an irrigation client, something like Spotify, just with a real use case. I have these dbus interfaces here, much like let me show you those. Where is it? Nah. What am I doing wrong? Irrigation local. Sorry for the jumping around. But here's the dbus interface. It's much like the Emprise player interfaces that I showed you right before. This is the system, the irrigation system, which contains, in the local case, these irrigators. It has a method. This method is async as opposed to the other binding. This is using the Python async IO binding of the sdbus. Get irrigator names, tomatoes and beans, and it emits a signal, which I will get to later. And the other interface is an irrigator which only has properties like name and low mark, high mark, current moisture value, and current switch state. Such an irrigator exports these. So now I import this, knowing that this is async. This new proxy method here of the interface, of the irrigation interface, generates me an async proxy. But anyway, this looks like an object. This irrigation system, the variable, looks like a variable that can do me this. Let's try this. Let's do this naively, and let's say get irrigator names. Yeah. So let's say names is equal to. This won't work. This does not work, obviously, because this is async. This is async, and async says irrigator client do me blah runtime. It's a bit of a pain. Coroutine blah async call add was never awaited. And for those of you who have already programmed with async, they know that anything that can be awaited should be awaited, because this is an asynchronous. A request is sent out, then something is done in between, and then the request comes back, and the event loop schedules my coroutine, although there is no coroutine now. So what does the thing say now? Await outside function. And obviously, what it tries to tell me, this await has to be inside a function which has to be async. This is the full async dance that I have to do. .run, and then I instantiate the coroutine by calling it async, and then the program is done. Much like the program that I had before in a synchronous way, but a little different. You have to say await and async and all that. And here you see, we got tomatoes and beans, the names back. So what else? That's it. Yeah. What about the irrigators? I don't call this client to see the names of the plants that I water, that I give water to, but I want to do something with the names. I want to, much like the irrigation system, I want to instantiate proxies for each irrigator for switches and sensors. So let me do that. Irrigator is equal to, that's the second interface that I imported up above, dbus irrigator, that's it. New proxy. I copy the parameters from above and say, the bus is the same. The service name is the same, but it's just the object path. Let me make this an F string and say name. Yeah, substitute name here, and then say sort them into a dictionary which contains all these irrigators. Irrigators name as a mapping to the dbus proxy that I just created. Yes, that's it. And then let's use it, and then let's for name and irrigator. It's about the names. It's in irrigators items. Let's say the low watermark of this irrigator is dbus properties and function calls are always bicapitalized. If you write it in the specification with an underline, in this snake case, it automatically converts it to bicapitalizedness. So I write uppercase low here. That's the reason. So I wait for the property. This is the property, and it corresponds to this one. When I write low, coming out of the local, I pull the version, the property out of the local that I'm mapping to dbus implementation, and just say dbus, hey, transport me this property to the outside, as I just told you. So that's happening here. Hi. So moisture value, await irrigator, moisture value. This is, sorry for that. Switch state. Switch state. And then print something. Print statistics of name. Name. Low. Let's omit low. I'm interested in these moisture values, the sensor values, and the switch values. Switch state. Okay, and let's say do this in a infinite loop with a back of 1 second. You have to await time just as well, because you are not supposed to block anywhere in an async program. And when you're done with that, you see the syntax error. 18. You saw that in names. Yes. That's it. Every second. Statistics. So how can that be async? Does this necessarily have to be async? I suppose no, because what this program does, it gets a couple of proxies, sets up the system, and then it does some linear work for sleep a second, get properties, print, sleep a second, get properties, print. This is single-threaded. This program is single-threaded. It could also be blocking. I could be using the blocking interface of the sdbus interface. But no, this is not fun, and it is not powerful. This is not powerful. Powerful because what else could I want to do? I want to show you. Time is running out. How signals. This is a signal, dbus signal async. This service emits in the opposite direction from the service to a client a signal, an event, a whatever, a callback, so to say, a callback. So, and the signal is called switch state changed. And this is something that I want to see too in the client in parallel. So now we are I'm using async for event. That's the event. This is how these signals switch state change. The irrigation system emits switch state changed signal, and what comes out of it are the events. So, and this is how you do this in async, in async I/O, because the for loop alone, without async, would block in the next function of the iterator in Python. This is how for loops in Python work. It calls next, and no matter what, next sleeps until there is something to have. This is not async, blocking there in the next of the iterator, and this is what the async for loop has been invented for ages ago in Python. And let me see how this works. This is very simple, and this is, I mean, async is definitely not simple. It's not simple, but this is definitely simple. You just have to take care and not forget any async. And yeah, how to change the switches. Yeah, switch changed. So let's say 100. This is not an event because the plants are already drowning and the switches are closed. Let's say completely dry in both areas. And this is the event that I get, a dictionary. This is how I specified it, dictionary. So which switches have changed. Okay, so next. We want to do both in parallel. So let me move that up. I got only 5 minutes left. Got to really hurry up. And create and say, let's cram this into two functions. One is the status loop. Nah, getting nervous because time is getting tight. And this is an async dev report events, something. Yeah. It uses global variables. This is not about program sanity. It's about async. And these are just async routines, and I want to run these in parallel. This is what I do, and now we enter another async with, you know, the with statement in Python. There is also just like the for loop, there is a with statement in async, which enter and exit. It's a callback like enter and exit, which could block in async. The async with defines a enter and a async, which don't block. So let me finally create a task for the status loop by just starting it. And then the report events loop task to start it. I have global variables. Global. Let me make sure that because I see I'm assigning to irrigator here. So to make sure, I just yes. Okay, two async methods which should run in parallel, and this is where tasks, async tasks, come into play. So that's it. That's the status loop. So now let's prove that switches still change and are reported as such. So moisture 100%, and the parallel client on the left side should then. Yeah, it runs two loops in parallel. One loop with sleep 1, report status, and one loop which mostly blocks unless an event, a signal comes out of the debug service where I'm registered with. Yeah? Two tasks in parallel. So I'm really tight with the presentation. I would have liked that not to be that way, but anyway, I'm done. Any questions? We have 3 seconds. 3 seconds. Okay. I mean, debus is over-engineering. It's complex, and I have used the other bindings, the debus, the libdebus binding, and the GIO binding. I have used them. They are pain, one more than the other, but really pain in the ass, and I don't like pain. And since this SDBus implementation came into public, I'm using only that if I'm doing such things. I do such things very rarely, and I don't want to be hurt if I do it occasionally. And SDBus is really cool. Yeah, that's really cool. If you're into Python, async, and if you're into fun and pain, because if something goes wrong in async, this is conversely that is painful. I mean, nothing can be done right, but fun is done right, I think. Yeah. Okay.
So I have a question about, I don't know if this is relevant, but I noticed that, so the interfaces, so for example, Spotify's interface, it has the play pause method exposed, right, through the dbus interface. What happens if Spotify upgrades and they change their interface? How do the client, how do dbus clients know?
I mean, these are version issues that have to be handled at a specification level, I believe. I mean, whenever you design interfaces, even especially remote interfaces, you are supposed to take care. No Spotify here. Let's look at the others. Irrigation. There you always see this file manager 1. This is popular. File manager 1. This is the first version of the file manager interface. This has to be baked in up to eternity, unless it breaks. It is supposed to break. Then they remove the 1 interface. If they make it 2 interface, as we saw with the media player. The media player was called media player 2. Apparently, this is the second version. They had one and kicked it away. At least Spotify does not implement version 1. It implements only version 2 because reasons. But file manager is more critical in a desktop scenario, so they have to stick with 1, which is what they did. They add methods and properties, I can imagine, incrementally, but not breaking the existing stuff. Yeah?
That makes sense.
I'm not a dbus expert. I just get into it sometimes and discover new things, how the desk. I mean, if you know how to do, you can always suspend your PC from the command line by using a dbus call there. It's just a matter of finding the method where in the fucking 3 service object interfaces where is my suspend method. Yeah, this is the challenge. But the technical issues, at least with SDBus, are gone. Yeah.
Thank you. That answers it.
Okay. Thank you.